I thought I'll bring up a topic which probably, can bring all of us together, affects all of us from the industry. We all, showcase all the good things that we've done, better designs that we're achieving. A lot of times we tend to ignore some of the misconstructions and the fallacies, the mistakes that we commonly either make or we come across in projects. As in my introduction, I'm representing Cold Steel Corporation, but I will not be talking about my company, but I'll talk about the warehousing and the industrial PEB industry at a large, and mostly what are the misconstructions, fallacies we usually face, at the design stage, at the conceptualization stage, and then finally at the execution stage. I'll take you forward. So most common misconceptions, usually when projects come to us either at a tender stage or at a pre-tender stage or at a quote stage, BOQ stage, the most common mistakes that we usually come across, that they're already done in the buildings, and either the developers, consultants, designers, end users are always wondering and, chopping between these choices and questions. The building orientations and spans, what should be the orientation? What kind of spans do we need? Service loads, what kind of loads do we go into? The design codes, right? What materials should be used? Who's accountable for what? Who takes responsibility for which part of the building? Prioritizing the budget allocation, we have a limited budget, what goes where, into which stage? And of course, Indian obsession for the lowest one, we always keep talking about this term, the L1 term. So that's an obsession we have to get rid of. So how many here have actually faced this problem at a concept stage where you have a piece of land or a plot where you're still trying to come up with the exact and the best orientation of the building? When we say orientation, it's both external and internal orientation. I mean, that's a very common thing. You cannot simply look at the piece of the plot and try and cover the maximum possible area and then, try and work towards it. So I believe this is a common issue with a lot of people here who either have designed buildings or in the stage of coming up with projects or setting up new projects, right? So this is a very, very common issue and number one issue that people usually face. What is an ideal span? Now, when we talk about span, basically it says what should be the width, clear width of a building between columns. So what is an ideal span? Now, there is no such thing as an ideal span. It depends on the usability of the building. What are you making it for, right? Instead, a lot of people try and copy spans, okay, why I would need 30 meters, I need 40 meters. Why? Because I saw it somewhere, I liked it, there's more room, there's less columns. Not necessarily that is what you require. You don't necessarily require a 30-meter span. Sometimes you're perfectly fine with a 15-meter span, and it gives you a far more economical design because the roof becomes much lighter, and it still doesn't hamper your operations. So it should actually be driven by your operational requirements and not so much by, your obsession for either going for large spans or for some whims and fancy which says, we want to have 20 meters or 30 meters or 40 meters. I've seen buildings we've made ourselves building where the client has insisted, please give us 30-meter, 40-meter spans, and then along the columns parallelly they park, either machines or racks and something like that, and there is no need for, the columns to be spaced that far out. Similarly, does a building require jack beams? A lot of people sitting here already understand this term, jack beams. We remove intermediate columns, we put jack beams. We could remove either one or two intermediate columns, sometimes 3 intermediate columns, have jack beams up to 20, 30 meters in some places. So do we require them? We don't necessarily require them all the time, everywhere. I think it is now becoming more of an obsession. You see a building, you quickly go ask for jack beams. Remove all intermediate columns, put jack beams, irrespective. Not necessarily. So again, it depends on the operations, it depends on the usage of the building, and the end users and the designers and the builders need to sit together and find out an optimum mix where they figure out maybe we require jack beams at 5 locations and the other 20 locations we don't require them. Or in certain cases, if you do, then so be it, can be done. Which side should the docks be? Now, this is a very, very common area of concern in most large warehouses. You have large warehouses and you have a row of docks or shutters, as we call them, or openings with canopies along the sides. Now, why do the docks always have to be on the side? Why can't they be placed more towards the gables? Because towards the sides, you have the rainwater gutters, the downtake pipes coming down, then you have the canopy, and that becomes an amalgamation of all the water coming down and all the material going in and out at the same place. So why can't we not kind of, rethink this idea, not necessarily have all the docks on the sides only, maybe try and have them on the gables. Usually these buildings have large gables. When I say gables, that is the width side of the building. So we can have them. There's no rainwater channels there. There's no water there. So it becomes an easier thing. Operationally, it won't have an impact, but that can be driven if you have the orientation right in the first place. You can't have the gables with lesser space and then put the docks there. So these are some very common issues. I can't be giving solutions to all of them right now to have a short span of time. So I'll just be covering through most issues that, areas where these misconstructions happen. Service loads. This is again, so let's imagine there is a project team sitting where you have the owners, maybe the consultants, maybe the HVAC team, the owner's management, and there is a discussion going on as to kya loads lagane hain building mein, right? So obviously consultants want things on the safer side. They'll say, we must have a live load of at least 75 kg on the roof. Let's not go anything less than that, right? Sure. So of course, the next step is solar panel. Yeah, everybody wants solar panel nowadays. So we'll put additional 25 kg load for the solar panels as well. Perfect, why not? Then do we need additional loads for the lights and fans and cables? Somebody in the meeting will say, of course, bilkul chahiye sir. Light bhi lagani hai, hame pankha bhi lagana hai, hame cables bhi run karne hai, hame ye bhi karna hai, hame wo bhi karna hai. Acha, lagai. ठीक है sir. एक somehow somebody will come up with a figure, 20 kg लगा लेते हैं sir, 25 कर लेते हैं. चलिए, वो भी लगा दिया. How about sprinklers? Somebody will say. Sprinklers चाहिए, firefighting चाहिए. Right, of course. Firefighting तो बहुत ज़रूरी है. So somebody will add, okay sir, without having proper breakup, they'll add another 20 kgs, 25 kgs for firefighting loads. Right? Some smart guy in the meeting will say, who's kept quiet all the while, says, मैंने तो कुछ बताया नहीं अभी तक. मैं भी बताता हूँ. साहब, ducting लगेगी, ducting load लगेगी. Okay, यार, ducting तो हमने कभी लगाई नहीं, सब लगाना चाहिए, बाद में ज़रूरत पड़ सकती है. Okay, ducting load भी लगाइए. 15 kg ducting load लगा दीजिए. वो करते, there's so much sugar added to the tea that 250 kilo का load हो गया, पता चला. Right? But when it comes to paying for it, the owner is still sitting on his tight budget, right? He doesn't want to pay for it. And of course, you're unnecessarily overloading a building with all these loads, one on top of the other. Whereas they can be very easily dovetailed. The code also allows, if there is a 75 kg live load, then you need not necessarily add the solar load to it. You cannot have the solar load and the live load together at the same place, unless you have people standing with the panels on the roof. Similarly, the lighting loads, especially with these LEDs, the cable loads, the ducting loads, are well taken care of within the safety margin of 75 kg. But for the safer side, you can probably add another 5 kg or something, which is also a fairly large load when you say spread over an area. So this is another area of discussion we come across very often, what are the areas? This is area which is, again, needs to be discussed. We have the industry experts here. Something we need to dwell over and not necessarily keep overloading things. And then finally, not be then willing to be paying for it. Unnecessarily, we'll also be wasting money and budgets for stuff that's not needed. Design codes, right? We had this discussion yesterday, probably today as well. What design codes to follow? Sierra sir were here, and he was explaining that, there are so many design codes going around nowadays. People are not very commonly happy using Indian codes. So we're using MBMAs, AISC, IBC, and there is always confusion, right? So this is again, this must come from the industry. Together, the industry experts, now is the time when we must form consensus and understand that which codes are finally suited, especially for the warehousing industry, for the industrial segment. There's too much confusion, too much back and forth. Should we use limit state? Should we use working stress method? Is any one of the two better? Should we be rigid about it? I think we have reached a stage, we are mature enough in the industry where we need to come with a consensus, come on board and come with a consensus for this. This is usually, again, a huge bone of contention. A wrong code being followed for a wrong building can actually completely, wreck up the whole philosophy of design and the budgets. Which materials to be used, right? What is the ideal material for roofing? Should I go for bare galvalume kind of a sheet? Should I go for color-coated sheets? Should we go for aluminum sheets? Should we go for puff panels? You know, this is a very commonly asked question. Invariably, people don't come up with the right choices. When we try and give suggestions, understood as vested interest. So, is high tensile steel of any advantage in any project? A lot of people try and sell high tensile steel. Now, high tensile steel is only beneficial if it's about stress in that section. When it comes to deflections, high tensile or low tensile is of no meaning. So, not necessarily go for high tensile. Don't try and find which is more optimum for the project, for certain sections within, primary sections, stress members, yes. Secondary members where deflections are the criteria, not necessarily required at all. Is insulation necessary? We've had a presentation on insulation. Is it necessary? Yes, in certain cases. In certain cases, no. We've had buildings which are open on the sides, completely open from the sides. They have heat being produced in certain small segments, and people still ask for insulation on the top. So it's basically wearing a blanket in hot sun, you still remain warmer, right? And there are other cases where people actually don't go for proper insulation despite having the need for it, because then they somehow want to cut down on budgets. So again, these are the questions that the industry now must come together, and it's the end user at the initial stage must be given the right advice. Why should galvanized steel be used? Yes, there has advantages, but again, we did not use galvanized steel everywhere, right? So this is again a question where the consultants, the designers, the end users, and the manufacturers can sit together and find out an optimum mix of which materials to be used finally, which kind of gives the client all operational benefits, but it is not high on his pocket. Prioritizing the budgets, Usually what happens is that by the time the building is to be built or to be quoted for or to be tendered for, the budgets are already drawn, right? By the time we reach a stage, the budgets are already drawn. The client says, "Mera ye budget hai, mere paas ye fixed budget." How do they come up with that budget? Right? That is one thing. Also, how do they prioritize now within an X amount of funds to be used? How do they prioritize which part goes where? So there are certain areas in a building which cannot be rebuilt, which cannot be upgraded. You cannot upgrade the foundation of the building. You cannot upgrade the structure of the building. You cannot upgrade, the main members of the building for the next 30, 40, 50 years. What you can upgrade? You can maybe upgrade the cladding. Maybe you can upgrade the flooring later on. Maybe you can upgrade the facades. Maybe you can upgrade the electronics. Maybe you can upgrade the shutters, the HVAC systems. So if you have limited budget in the phase one, please put that budget for the core, which cannot be upgraded later on, right? I've seen people with very tight budgets, but then spending too much money on other areas, which they could have probably spent a little later or was not necessarily required, in large landscapings and large facades, and yet cutting the costs where it matters, not going for insulation, not going for better steel, not going for better spans, cutting the budget there and then spending it somewhere else. So this is again an area where we can kind of, be smart about it and find out the differentiate between the one-time capital cost and something that can be upgraded later on. And of course, our favorite topic. So this one is my saying, Rome was built in a day, but more importantly, it wasn't built by the lowest bidder. So our obsession of somehow chasing the lowest one, the lowest bidder, right? So this is something we need to again change as a philosophy, as a kind of, the obsession that we must finally give the order or find a contractor or even a consultant or a service provider who is the lowest one in terms of pricing. I think that's not really always the criteria. We shouldn't be doing that. I hope some of these insights have kind of, brought us all together, because these are common areas where we all face issues on a daily basis. Thank you very much for the patience.